Hi everyone. I wanted to show the debugging that I did for the last video. So when we left off last time, I noticed I had a bug in my code. I wasn't sure what was going to cause it, and I wasn't going to just try and live debug something because it's an unknown amount of time. It could be just an absolute rabbit hole that I'm going into. So I wanted to make sure that I knew what the bug is, but I wanted to also walk through what my thought process is for debugging, just because we really need to sort of ingrain that into sort of a methodical way of reasoning about code rather than just throwing your hands in the air and just giving up. So last time we talked about this, I can actually run the code here, and I'm just going to continue, just so you can see what we had last time. What I was trying to do is I'm trying to remove from the end, remove from the start for each one of my linked lists, just to test out that method. And what we had initially was, here's 4 elements, and now we're down to 1. Something weird happened, and I wasn't sure what would be causing that. It happens to both doubly linked list and a normally linked list. The formatting of these things are different, but here's a normally linked list, deleting 1 element, and then here's the doubly linked list, deleting 1 element. There's something happening, and so I'm pretty sure it's not in doubly linked list, but I don't know where it is in linked list. If it's in linked list and that also propagates out to doubly linked list, if it's something in my call to in my demo call, where the heck the bug is, right? It could be any number of places. And so my first approach is, well, if I don't have a breakpoint, I can put in a printf statement, but in this case, I can't put in a breakpoint. I'm going to put a breakpoint right when I remove an item. So let's run it again. I get a breakpoint when I remove an item, and I'm going to go into that breakpoint. This is F11, or in this case, where is it? That's step over, that's step into right here, if you want to use the icons at the top. Okay, I'm in RemoveEnd, and I want to look at what's going on with RemoveEnd. So I'm going to go down a couple lines. Okay, I know I have 4 elements in my array, or my linked list, sorry. And then I'm going to get the last node, and so that should be fine. I make sure that the last node looks correct. Yep, looks like the last node there, right? If there's an actual link, and the next element is null, what we'd expect. I make sure that if there is a last node, that's fine. I'm going to get the previous node. That looks, here's my previous. And okay, so that's my last. This is my previous, and it's going to point to something, and I'm going to see if previous is equal to the last. No, I'm going to assert that the previous exists, and then I'm going to set the next. Now, I want to take a double check of this one because I'm still not 100% sure. Let's look at what previous points to. So here's previous, the previous node. It should be pointing to my next, right? And my next, wait a second, there is still more next stuff here. There is still more next stuff here. There's my last node. Here is where it said previous was. It's actually the very first element in my linked list. What the heck's going on? Why is previous wrong? That's what the issue is. So I've done I know something went wrong, and I'm pretty sure the last is perfectly fine. So the only problem must be that the previous was wrong. And I know, and that makes sense. That's why all the elements after the very first element are removed, because I'm breaking the bond between the previous and the next. Well, if the previous was way the heck at the beginning, there would be a problem. Let's also point out one other thing. So let's close that part here. I'm going to stop my program one more time. I'm going to add one more. So I'm going to get the previous, and if the last is equal to start, so that's only a single element or no elements. All right, I'm going to assert that there's a previous. Let's also assert that p previous get next is equal to p last, right? The thing I'm going to remove is equal to the thing I want to remove, right? That should also be true, because the previous should point to the last before I remove it. And that's not going to be, in fact, the case, but I want to look into this. So the get previous node, this would be a perfectly good test to add on just in case I ever make this kind of mistake again. I can always add these tests. It doesn't hurt anything at all. All it does is a sanity check for my code. Okay, so here is my previous node, and so even if I miss a test, by the way, I can always add it later just to be on the safe side later on. So when you're talking about unit testing later on, if you're in industry, if you miss something, you put in more unit tests. Why? Because it's tests that you know that should work. I have a bunch of kids that might be trying to talk to me right now, so I'll try to not disrupt this lecture any more than I have to. Anyways, here we go. Here's my previous node. I need to look into this. That's what I want to look into. That's the function. I'm pretty sure that's where my mistake is. So let's run it again. And I'm going to keep on. I'm just going to go press continue because it's going to stop right here, right where I want it to stop. And I'm going to drill into this thing here, and I'm going to get my previous node. So let's walk step by step. The node I'm looking for exists, so I shouldn't go in that condition. I'm going to check. I'm going to start at the start. And while current is not equal to null, and while current.next is equal to n. Wait. Notice I don't even go into that. Oh, I did go into. Sorry. Let's pop out back again. I should go into this while loop, and I'm not going to. Why? Because of that. So easy to overlook, and you can spend days looking for it. This is why you need variables that make sense. This is why you need functions that make sense. I'm not going to claim that my code is perfect by any stretch of the matter, or that it's extremely easy to understand. But that's always the goal, that you can actually read the code, because you're not going to remember what you wrote, or it's going to be some little finicky thing like this, that instead of an double equals, that's wrong. What I need to say is, if the thing I am not looking for, if the next is not n, then keep going. When I find what I'm looking for, I want this thing to stop. It's the exact opposite of what I had, and yet all it is the difference between an exclamation point and an equal sign. Okay, so this is my hypothesis. This is what I'm going with as the solution. Let's compile it again. Let's see. If it doesn't fix the problem, I'll revert it. But if it does fix the problem, well, then we know what the problem was, right? This is a pretty good guess of what's happening. It's finding the previous way too early. It's getting the very first element, and it's deleting everything after that fact. Alright, so I'm going to get rid of my breakpoints everywhere because you're not going to see squat when we're doing this. And here's my code. I'm removing the 5, and then I'm removing the 2, and I'm getting this. Here's my linked list. I'm going to remove the 17, and then I'm going to remove the -3. Remove the -3. Hey, that's working. Everything's working now because of one stupid little exclamation point missing and having an equal sign instead. So, we've actually debugged our code, which is hopefully nice. It makes me feel a bit better. By the way, just wanted to check something. Yeah, I'm recording.